Previously, we've been proving triangles congruent, and we can prove triangles congruent by side, 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 angle, side, angle, HL, and angle, angle, side. So those are the existing 5 theorems or postulates that we can use to prove triangles congruent. In Chapter 8, we're looking at methods to prove triangles similar. So this symbol means congruent triangles. The single tilde in front of the triangle means similar triangles. So we know if we have 2 triangles with 3 pairs of angles that are congruent, then the triangles are similar. But we don't need to show that all 3 pairs of triangles are congruent because we have no choice. The no choice theorem would tell us that that 3rd pair of angles are congruent. So we only need to prove 2 pair of congruent corresponding angles in order to say that the triangles are similar. We can say angle, angle, similarity. Write the tilde after the AA to imply that it's similar. Just like we had side, side, side congruence, we now can have side, side, side similarity. So that tilde becomes extra important. That means if AB is to DE, the same way that BC is to EF, and AC is to DF, if those ratios are the same, in other words, we could take this triangle's lengths here, multiply it by 10, and get those lengths, then the triangles are similar by side, side, side similarity. We also have side, angle, side similarity, and again, the angle needs to be included or between the 2 sides that are proportional. So here we have if AB is to DE, the same way that BC is to EF, and the included angle B is congruent to the included angle E, then we would have side, angle, side similarity. Let's look at some examples. In example 1 here, we are given that ABCD is a parallelogram. If we have a parallelogram, then we know that opposite sides are parallel, so AB is parallel to DC. CDF is congruent to angle E, because if we have parallel lines, then alternate interior angles are congruent. And DFC is congruent to EFB, because if 2 angles are vertical angles, then they are congruent angles. Then by angle, angle similarity, from lines 3 and 4, we know the triangles are similar. In this example, LP is perpendicular to EA. That would make angle 1 a right angle and angle 2 a right angle. If 2 angles are right angles, then they are congruent. N is the midpoint of LP. So that makes those 2 sides congruent. And P and R trisect. So in other words, if we call this X, then this would be 1X, this would be 2X, and the distance from L to P, which I'm going to mark here, would, if this is Y, This would be 2y. So that would make triangle LPA twice as large as triangle NPE. Given that the included angles are congruent, we can say that the two triangles are similar by side angle side similarity. In our third example, we are given that KH is an altitude to the hypotenuse of GJ. Now, this problem will come back again in Chapter 9. We need to prove that KHJ, the small triangle here, is similar to HGJ, the overall big triangle. So if this is an altitude, then that's a right angle. And if this is a hypotenuse, then this is a right angle. And if two angles are right angles, then they are congruent. So now we can say angle J is congruent to itself by the reflexive property, then by angle, the triangles are similar. So let's just talk through a few more problems. If angle A is congruent to angle D, and angle 2 is congruent to angle 4, those are given. Angle 1 and 2 are supplementary. Angle 3 and 4 are supplementary. And from 2.4, we recall that angles that are supplementary to congruent angles are congruent to each other. So then the triangles become similar by angle similarity. In number 3 here, we can see that NPRV is a parallelogram, which would make those sides parallel. And then parallel lines implies alternate interior angles congruent. And actually at this point I have a couple of choices. I could say those two angles are congruent because again, parallel lines implies alternate interior angles are congruent. Or I could reach my second pair of angles that are congruent because vertical angles are congruent. But in either case, I will find that the two triangles are similar by angle similarity. So in number 4, we're given AC is congruent to AE. If two sides of a triangle, that's triangle ACE, are congruent, then the angles across from those sides are congruent. We were also given that angle CBD is congruent to angle EFD. So again, by angle similarity, the two triangles are similar. In this proof problem, we are given trapezoid ABCD with bases AB and CD. We need to conclude that triangle ABE is similar to triangle CDE. Trapezoid ABCD is given. If a quadrilateral is a trapezoid, then the bases are parallel, so AB is parallel to CD. If lines are parallel, then alternate interior angles are congruent. Thus, angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4. And lastly, if two pair of corresponding angles in two triangles are congruent, then the triangles are similar by angle similarity. If we are given angle G is a right angle and angle K is a right angle, we know right angles are congruent. And HJ is 1/2 of MO. We're only given information on a side and the angle across from that side, and we don't have any theorems that would speak to that, so we can say no similarity can be found. Or that it can't be proven. In number 11, this is an indirect proof. So remember, in indirect proof, we always start with the opposite of what we're trying to prove. So either A prime, C prime is 12.3, or it is not 12.3. We always start with the opposite of what we want to prove. So I will begin by assuming that A prime C prime is 12.3. Then we can see that AB is to A prime B prime the same way that AC is to A prime C prime, the same way that BC is to B prime C prime, such that the two triangles ABC would be similar to A prime B prime C prime. And at a side note here, if we took the lengths of the sides of ABC, 2, 4.1, and 3.2, and multiplied them by 3 by distribution, you can see that we would get the length shown here. So here we have proven that triangle A prime, B prime, C prime is a dilation. It's 3 times triangle ABC. So they are similar. But we are given that it's not a dilation. Therefore, our assumption must be false, and A prime C prime is not equal to 12.3 is the only other conclusion. If you found this video helpful, please like and subscribe. Smash that like button.